Hey guys, this is Mr. Fernando, and I am here to show you guys systems of equation using substitution. So just like as a big picture, we're still doing systems of equations. Systems of equations being where you have two or more equations that have the same variables. So previously we've done system of equations where we're graphing them, right? So this is an example of where you have one equation right here. I'm just gonna like circle it right here, where it has like a slope and a y-intercept, and you could graph it, and you could graph this one where it's like, a slope of rise over 1 and 4, minus 4 being like the y-intercept, and you could graph it. And then this spot right here was called our solution. So that's what we're actually still aiming for today, except using substitution, we are not gonna graph today. So to show you a problem, right, I'm gonna go to our actual one. We're going to be doing substitution. We're using algebra to solve and do the same thing. We have two equations where they have one answer, one solution, where, if you graph these, they'd intersect, right? So like these ones are also graphable, right? This one you could graph this, and you can go onto a graph, and you could graph it, and you could find that intersection. But like I said, we are going to be using substitution. So what is substitution? Well, again, I'm gonna go with the baby form, right? I'm gonna start with something that I think all of us can do. If I gave you something like this where it said x is equal to 5, and I said 4 plus x is equal to question mark, right? And if I asked you, what is that question mark, right? 4 plus x is question mark. What's the question mark? Hopefully you're saying 9, right? Well, why do you know that? Because I said x is 5, right? You're substituting this in your head, and you're maybe hopefully going like this. 4 plus 5 is 9, right? That's substitution. This is just the baby formula, right? But we're gonna just use that same idea to solve this, right? So think about it like this now. I'm gonna make a claim. I have two equations, number 1 and number 2, right? And I'm going to read out that first sentence. I'm saying y is equal to x plus 16. So just like my baby one, right, where I said x is 5, I am making a claim that this right here, that is y. I have said y is equal to this, which means if I substitute it right here, right, that's y. And that's also y. So you can substitute or switch them in, right? You're saying y is this, so you can put y, or what I just highlighted, right there, right? Because this is a system of equation. These equations can interact with each other. So what do I mean by substituting? I am quite literally going to take this right here, and I'm going to place it right where this y was. So I'm going to write x plus 16 is equal to 5x minus 12. So all I did was I rewrote this sentence, except I substituted the first sentence or the first math statement right here, because I said, y is this? Okay, so I'm gonna put it right there. So, well, I have an equation now. I have an equation that I can solve for. So your step 1 after you substituted is solve for x. So I have x plus 16 is 5x minus 12. Well, if I'm going to solve this, there's quite a few ways of solving this, but I'm going to go ahead and do minus 1x from both sides, minus 1x from both sides. Right, I'm solving for a variable, solving for x, and now I have 16 is equal to 4 x's, because I took away 1, minus 12. From here, I'm going to go ahead and add 12 to both sides. And you now have 4x is equal to 28, right? And you're going to just do one last step of dividing. 28 divided by 4 would give you x is equal to 7. Oh my goodness. Am I done? Well, not quite. But you did finish the hardest part. You substituted. You solved a big algebra problem to get that x is equal to 7. but you've just made another claim, right? You have now said that x is 7. So that means if I go back over here, anytime you see the letter x, you could put the number 7 instead because you're saying x is 7. So that's a 7, that's a 7. So let me solve for y now. I know I said y is x plus 16, and that's still true. That's still very true. If I wrote that now, if I wrote y is equal to x plus 16, the only thing I'm going to change now is I know what x is, right? So I'm going to go ahead and go, oh, that's a 7, right? So all I did was I replaced what I figured out into the gap. And y would now equal, if you added those together, 23. So you have x is 7, y is equal to 23. And then, again, just because I want you to think about that graph, that would be where they intersect. As a coordinate point, that would be 7, 23. My x and my y, right? If I graphed these, I would have gone the same thing. That's where they would have intersected. And that's substitution. You substituted a part of a question into another question. Use algebra to solve it and understand that as you get an answer, how can you use that answer? So I'm going to do it again real quick. Let's do it for this problem right here, right? So yet again, I'm making a claim. This right here, what I'm highlighting, that's y, right? Y is equal to negative 4x. So that means this right here, it's not y. It's not y. That is negative 4x. So I'm going to substitute this thing right into there. So I'm going to rewrite what I have. Negative 4x is equal to 3x plus 14. Well, okay, so I have an algebra problem again. I'm solving for x. I'm solving for my variable. So I have, that's a really weird looking negative. I'm going to try to consolidate my x's onto one side. So I'm going to go ahead and go minus 3x, and I now have 14 is equal to negative 7x. Divide by negative 7, and you'd get x is equal to negative 2. So, again, I know what x is now. So, this right here, you could technically write negative 2 right there. You could also write it right here. You're replacing the letter x with what you know now. So I'm going to go ahead and do that. Let's solve it. Let's do y is equal to negative 4 times x. What again? I know what x is, so negative 4 times negative 2. Well, y is then equal to positive 8. And I have my two answers, and written as a coordinate point, that would be negative 2, positive 8. And there you go. Substitution. I'll do one final time. If you're good now, you're good, but I'm going to speed through just one last example, right? So on this one, it's not the first sentence that says it, it's the second one, but same idea. I can see that at one point, it is saying x is equal to 3y. So this right here, that's x. This is the letter x right here. That means this right here, same thing. 2y plus 3y is equal to 15. So let's write that. 2y plus 3y is equal to 15. Well, I don't actually have to do any removal right now. These are all on the same side and they have the same variable. So I can just combine them. 2 yo-yos plus 3 yo-yos, 5 yo-yos, 15. From here, just gonna divide by 5. I shouldn't be doing that. I should be doing just divide by 5, y is equal to 3. So again, I know what my letter y is, or my variable y, it's 3. So that means this right here, the number 3. So let's solve for x. X is equal to 3y. That means x is equal to 3 times 3, which means x is 9. So my answer, 9, comma, 3. X comes first, then Y. That's substitution. That is elimination. That is using our algebra to solve a systems of equation using substitution. Again, you could technically graph all of these, and you could also get the exact same answers. Hopefully this helps, and have a good one.